Hello and welcome to this new edition of the Foojay Podcast. We're going to talk about debugging and observability. We work with debugging all the time, but how well do we know this common practice? Observability and monitoring are debugging at scale for your production.
Welcome to the Foojay Podcast, all your news about OpenJDK.
Lots of developers treat debugging like taking out the trash, running to the door with their hand on their nose, trying to get rid of that awful smelly bag. We don't learn it in university, and there is just so much to know, both about the theory and the underlying tools. But debugging hits dead end when we go to production. We can't place a breakpoint on the cloud. That's where monitoring and observability tools kick in. We'll discuss the fantastic things available for us in the JVM. Today we are talking to some very interesting people. I'll let you introduce yourselves so I won't botch the names.
Hey everyone, I'm Ties van der Ven, work for a company called JDriven from the Netherlands, and I have a special interest in software engineering fundamentals. I really like the why instead of the how, and basically that's in a way because of debugging. Because in the first 5 years of my career, I spent almost all my time debugging. And because of that, I started realizing, hey, this thing keeps going wrong. Can't I find ways to actually improve the code in a way that this can't go wrong anymore? You can say that basically all my current interests are one way or another related to 5 years of debugging code. I noticed I got quite good at debugging since I was solving bugs a bit faster than some colleagues here and there. And I thought, hey, that's a bit weird since I'm not smarter than them. So I'm obviously doing things differently than they do. So I actually took some time at some point to figure out what I was doing differently and wrote a blog post and a Java Magazine article about it.
My name is Marit van Dijk, and I've worked in IT for over 20 years in different roles in different companies. I recently joined JetBrains as a developer advocate just last July 2022. Prior to that, I was a software engineer at a Dutch retail platform where I worked for 5.5 years in 3 different teams. On top of that, I'm an open source contributor, conference speaker, occasional guest on webinars and podcasts like this one. I write articles that you can find on my own website, on Foojay, and on the IntelliJ IDEA guide. I've contributed an article to the book 97 Things Every Java Programmer Should Know, edited by Kevlin Henny and Trisha G.
Hi, I'm Johannes. I'm probably the youngest one in the round, probably by far. I started last year at SAP in the submachine team. We built the best JDK distribution out there. And we're having lots of fun contributing the open source project related to OpenJDK project. So for me specifically, I'm working in our team in the serviceability field. So I'm working mostly on profiling stuff. I wrote the JEP 435 candidate, which hopes to improve profiling for everyone. So that's also why I debugged the whole day today. Debugged interesting things, but mostly on the C++ side. My take, my entry into Java debugging is because I did some program analysis at university and even tried to do a PhD in this field. And then later, working in SAP, I decided to look deeper into the JDWP protocol, or Java Debug While protocol. And I worked like a quarter of a year on a research project in this field. A few weeks back, I wrote a primer into this protocol, and that's the reason why I'm probably here.
Great, everyone. So I'm Shai Almog, and I'm probably the oldest one here. I've been programming professionally for over 30 years. During this time, I've been a consultant, so I worked with over 100 companies, and debugging was sort of a secret weapon when you're a consultant, because you need to walk into a company where you don't know anything and still give something of value. During this time, I worked at Sun Microsystems for quite a long while, then Oracle. I built JVMs and did all sorts of that stuff. Wrote lots of open source code, lots of that, including founded Codename One and other companies. I recently wrote a debugging book for APRESS, Practical Debugging at Scale, that talks about the entire practice of debugging. I also worked at Lightrun, which is an observability tool that essentially lets you do debugging in the cloud, and did developer advocacy there and other things. I have a YouTube channel as well where I talk about debugging and an online course about that, Debug Agent. You can find me there. Let's get started with the questions, and there's sort of questions for everyone, so feel free to answer them. I talk a lot about debugging, and I use IntelliJ IDEA, Marit. I know it's great. It has remarkable features, but their discoverability is relatively low. Developers just don't know how to use these amazing tools, things like marker objects, renderers, etc. How can we educate developers around these subjects?
I think that's a great question, which ties in with my job nicely. And I have to say that, first of all, I think IntelliJ IDEA is a great IDE, or I wouldn't have taken this job. I've been saying that for years prior to joining JetBrains. And I think it's great because it lets me do my job without getting in the way. And it didn't take me a lot of time to learn how to start using it, other than unlearning, saving all the files. But it is the only one that I found that really delights me in that it offers me features that I didn't even know I wanted, whereas the other ones or other IDEs that I've used don't. But it's also a very powerful tool with lots of features. And I think not everybody might know what features are there, or they might not always be obvious. So there are two tips that I have for people to find those features. One is to use search everywhere, which is just shift, and you can look for whatever you're looking for, like profiling or debugging or any other type of feature that you need. And the other is find action, which is Command Shift and A on Mac or Control Shift and A on Windows and Linux. And then you can find whatever it is that you're trying to do, which really helps to find the features. So right inside the IDE. But of course, we can only search for what we know to look for. So another favorite way for me to learn about new features is actually pairing with other developers, because they will do something where you're like, what did you just do? And you learn some great new shortcut or feature or whatever. And those are like the unknown unknowns. And the only way to learn them for me is to see other developers, also developers like yourself who are talking about our tools and sharing what they find useful and why they find it useful. You can learn new things from that. And finally, of course, we have a lot of videos on our YouTube channel about debugging, some short ones by Mala Gupta and some longer ones by Igor Ushikov, who is the team lead in profilers and debugging. So he really explains in depth all of the options, and that's really great. And in addition to that, we have the feature trainer right inside the IDE. We have a guide with tutorials and tips, Twitter tips for short tips on tricks in the IDE, and of course the blog. And so we have different content in different styles, depending on what you prefer.
One of the things I've noticed, and I wrote a blog post about it for Foojay that should be out by the time you hear this, is that Visual Studio Code, for instance, chose the path of simplifying because of that discoverability problem. People don't know about features like trace points. So because they're hard to discover in IntelliJ, you need to know to control click in the side in the gutter area, or need to uncheck the suspend option in the breakpoint dialog. And in VS Code, they made it much simpler. But on the other hand, they removed a lot of the functionality that's more complicated in order to make that feature more discoverable and other features more discoverable. And to me, as a person who does a lot of debugging, and by the way, I'm very much connected to what you said about pair programming, because I started learning about debugging 26 years ago from a mentor who I sat down with. And I think that choice is problematic, but I noticed that some people just don't know what they're missing out on because of that discoverability problem. One of my thoughts was the Code With Me feature that JetBrains has that lets you pair program remotely, because lots of us are more remote now than we used to. So that's probably also a good way of discovering things. And shameless plug, also my blog has lots of information like that about IntelliJ capabilities and videos.
Because IntelliJ IDEA has been around for so long, it has a lot of features, and we make obvious choices to not put everything directly in the UI because it would just get cluttered with too much stuff. The downside being that people don't always know what's there, and that's why people like yourself who are enthusiastically sharing what they've learned are really, really great. And any way that you can pair and code with me is the way to do so remotely and learn from each other is really great.
What I found interesting when looking into different ways to use profiles, especially into the differences between VS Code and IntelliJ, I found that VS Code uses essentially the code from Eclipse. So that's interesting from the technology stack perspective. That I think one of the reasons why VS Code doesn't have that many features is that they choose to work with the Eclipse code base. And as far as I remember, because I'm also an IntelliJ user for a long time, is that Eclipse has had less features. So I think that's also one of the reasons. And what I found interesting when looking into the protocol as a whole, that the thing that I use all the time, which is the evaluate code feature of IntelliJ, how it's implemented under the hood, because if I may elaborate, it's really a cool feature because what most people think is that, hey, yeah, it gets sent to the JVM and the JVM does everything. But when you look deeper and look how it's implemented directly on the JVM, it's essentially that your debugger in your IDE contains a Java interpreter. It's a Java interpreter that essentially interprets the Java code that you put in. But every time you say, okay, you write a local variable or, for example, call a method, this is then relayed to the JVM using the JDWP protocol. And so it's quite instrumental to not only learn these cool new features IntelliJ or Eclipse or VS Code have, but to also learn how they affect the performance. That's interesting because it's, of course, not that fast implementing it in an interpreter in the IDE side. And it's, if you have short enough build times, quite advisable to get larger evaluation code, for example, for conditional breakpoints or for watches directly into the code. There was a feature in JDWP, at least a while back. They had they had some space in a field for breakpoints where you could input a string. But the problem is it's for future use, as they wrote in the comment or the description, and so it has never been implemented. And I think after a while, with Kotlin, Scala, and other languages, it's quite infeasible that the JVM knows how to interpret the code, because then the JVM would need a Kotlin compiler, Scala compiler, GUI compiler, a Clojure compiler, or what else. And I think the IDE does a good job. But keep this in mind when you're evaluating in breakpoints that are used a lot of the time, or if you're doing it over the wire with the remote debugging features.
That's great. About JDWP, if we're heading in that direction, and the evaluate issue, both of them are very interesting. I actually worked at Lightren. We did an evaluate implementation that worked essentially in production environments, and it used also an interpreter written for efficiency, and it limited the overuse of conditional evaluations and things like that in order to not over-exert the JVM in the production. And this is one of the things that always bothered me. Some people make the mistake of trying to connect with JDWP into production. And that is insane in terms of performance, in terms of security, and also in terms of internal security, because a malicious developer, and 60% of hacks are internal, can just place a breakpoint in the place where users are logging in and just sap out all the passwords for all the users. And it's really, really easy to do that. JDWP is really it's a great protocol. It's just not designed for things like production. which is why we have observability capabilities.
I might just disagree on your part where you say it's a great protocol. I think for me, just as a context, I worked on this for a quarter of a year because I also saw that JDWP had some deficiencies and I wanted to solve it. And the main thing for people that don't know the protocol, which is essentially everyone out there, is that the protocol is written in a time where nobody thought about something like production debugging, or where nobody even thought about that you're not debugging in your own machine. No, security, it's a debugging protocol, so that's probably not an issue because when you can evaluate arbitrary code, then that's okay. Then you don't care about security in this regard. But the problem is it's an old protocol. It has lots of small packages. The protocol is really hard to parse because you have to know state, because, for example, they chose to reduce the size of the packages just by like 1 byte to not pass the type of the value. So if you have a packet, you have to, and this packet contains, for example, the value for field, you have to know the type of the field to pass it. So it's really hard to for example, integrate some JDWP parser into Wireshark, because you have to know the whole communication just to parse the protocol. Just for saving a byte. Also, a protocol has really small packages, so you don't get a lot of information, and it's nothing that you would currently probably write. And there is no Java implementation out there that can parse and generate packets and responses. I wrote the first, just a shameless plug here too. I wrote one. You can find it at my GitHub account under Part-Time Nerd. It's a protocol that's like from the 90s, and you see it. But the thing is, it worked, and people at JetBrains and also at Eclipse to do lots of things to make it usable again, and to make also the layer above it, the JDA, usable. And I'm grateful that they did it, because on the JWP level, it's not a great thing, and it's cool when you see, oh, I can use evaluate, and it has syntax and it has completions and everything, and you look at the underlying protocol and see how many thousands of messages are going over the wire. So please do yourself a favor, and when you do debugging, look that your server you're debugging is quite near to you, or at least if it's not that near, don't use conditional breakpoints with large conditions.
Yeah, that's a killer. And you're correct. I was being nice when I said, you don't normally say something sucks when you do a podcast, but you are correct. It does indeed suck. But to be fair, it's amazing that it works, and the layers that it has are fantastic. And no other platform has anything remotely like the JVM has in terms of the backend stack. JDWP is indeed very problematic, but I can tell you that we used that same protocol to debug phones, and I'm talking about J2ME phones back in the day. So you didn't have a regular TCP connection to the phone. You had to use @ commands, which I don't know if anyone here ever worked with @ commands. Trust me, you don't want to. And we were able to tunnel JDWP on top of that to do on-device debugging, which is fantastic. It's a very resilient, flexible protocol that does indeed suck, but honestly, the problem is also pretty humongous. And the nice thing is that it's wrapped very nicely, as I noticed you posted in Foojay, a great article about the JDI abstraction on top of that, and all of that level of abstraction. And this is a much more convenient API to work with if you ever want to actually implement a debugger yourself. Not that it's something that I would recommend that anyone does, but it's a nice exercise to do some automation and things like that, which is actually relatively simple to do in Java. And that's a small miracle, if I would say so.
If people do want to implement debuggers and other tools, we're always hiring developers, just me.
And I'm just very grateful for IntelliJ that they actually did that work, because evaluate expression is actually my favorite, like my number one used debug tool. Second being probably break on exception and breakpoints on condition. Those are basically the three I by far use the most.
If we're talking about exception breakpoints, I would recommend using them with the class filter. Otherwise, they're not very useful. And I wrote a post to Foojay about that as well. In exception breakpoints, they often stop on exceptions within the JVM itself, if you mark all exceptions. And that's just terrible. That's totally useless. But you can use a class filter in the exception dialog, and there's a video there and everything. I explained the whole thing. Check it out in Foojay. Let's move on. Any external debugging tools that are personal favorites of yours? Command line tools, the JVM has a lot of them, and also external tools. Personally, I love strace. I don't know if you've used it. It's a Linux command line tool actually built by Sun Microsystems before dtrace, which is amazing. So many innovations came from that company, and are still with us today. And when you run it with an application, even if it's a Java application, it shows every system call made by the application. And you can filter that list, obviously, so it won't run so slowly. But you can see every file opened by your application, every network connection, every sort of thing that requires a system call. And that's a really useful tool when you want to debug something and verify that your application is behaving as you would expect. Any similarly favorite tools that you have other than the IDE when you're doing debugging?
I know that as developers, we love to go for technical tools, but I'm actually going to go the opposite direction and say that outside of debugging inside the IDE, one of my favorite debugging techniques is rubber duck debugging, which I know from your logo you also like. So for listeners who are not familiar, rubber duck debugging is basically explaining your problem to a rubber duck if there is no person available. And by explaining your problem, sometimes you're able to figure it out, or just by structuring your thoughts, like what even is my problem, make some headway in where to look, and then you can look for technical tools that can help you figure that out. And in fact, my husband and I have a shorthand where sometimes we're talking to each other, explaining our problem. Midway the explanation, we figure it out, and we're just like, oh, just say quack. And the other goes, quack. Or if it's on chat, sends a duck emoji for, thanks for being my rubber duck. I'm sure Johannes has some technical tools, though.
For me, one of my technical tools is just doing printfs. Like, for example, I today hacked a bit on OpenJDK, tried to find a bug and fix a bug, and didn't find it, because in OpenJDK world, when you have a profiler bug, it's often a Heisen bug that appears, but you cannot reproduce it. And then for these bugs, it's quite hard. Also in the Java world, so the easiest options would be to simplify a problem. For example, you could do something like C reduce when you're in the compiler world to reduce your problem, or use tools from the functional world that allow you to reduce your problem case to a smaller case and test it all the way down. This really helps, because the best thing is to have a minimal use case where the bug occurs, because when you have a bug that occurs like on a large machine after a few hours in an unknown customer product, then you're essentially lost. So reduce the problem to something you can reproduce.
In addition to what Marit said about more in techniques, I don't have that many tools. I basically use whatever is needed. But in the debate comes down to, when debugging, one of the first things you want to do is reduce problem space. Because I usually work with a lot of enterprise applications, so like front end and a microservice backend in the cloud. And if there's a bug, I first need to figure out where it is. And step one, if something is wrong in the front end, I tend to use Chrome with the Chrome debugger to see network traffic, to see if is this value already wrong in the JSON, or is it correct in the JSON? So that means the problem is in the front end. After that, if I know it's in the backend, I can basically start figure out from what service it comes. And basically, I just need to figure out, after a bit of thinking with rubber duck programming indeed from Marit, what could it be logically? And otherwise, just simple things like curl from one pod to another pod, just to figure out what's going wrong. You don't need that many fancy tools. The main thing you need to do is figure out what is the most effective way to limit your problem space, that you're in the correct microservices and probably in the correct class as quickly as possible.
That's indeed correct. You need to split the problem and isolate it.
If you are very efficient in splitting down the problem, like halving the problem every time, then in like 2 or 3 steps, you're basically within 100 lines of code away from where the problem resides.
I love using curl as well. And one of the neat tricks I found in both in Chrome and Firefox, in the network inspector, you can actually get a curl command line. So you literally right-click the network request, and you can get values for curl or for Postman if you're so inclined, and just paste it in.
There. Yeah.
And it's so convenient. And unless you actually went out looking for it, you wouldn't know about it. Some of these debugging tools, like another one from Johan, when printf debugging, is so common. But lots of times when I need to debug things, I prefer using trace points, which is kind of like printf debugging, only that you can't forget it in the code later on. So there's sort of the similar advantages of not disrupting the regular execution of the code and coming up with something that you can still keep as a specific session, that you can do conditionally, etc. It does have a greater impact on performance if you do it conditionally, obviously, when compared to regular printfs. But I find that in the other regards, it's very, very useful. Let's move on to observability. As you mentioned, enterprise, it's required. You can't build a modern application without proper observability in the production. So the agent API is something that's, if you've ever used an observability tool, you'd usually bind it to the JVM with a Java agent or the native agent, etc. There's several permutations of that command line that allow essentially instrumenting a production application with almost no performance overhead. And having worked on an observability tool that's portable, not just for Java, but for Python, Node, and other VMs, Java pretty much stands alone when it comes to the level of observability that we can do, both in the power of the tools and in the performance. We were able to build a tool that has almost no real impact when it's turned off, still running in the background, but sort of just waiting for commands. And it had almost negligible impact. And a similar tool running in other platforms, not to badmouth those terrible platforms, cost 10% and more. So I won't name names, but pretty much all of them didn't perform all that well. So we were able to do some tricks to sort of work around some of that, but still the capabilities that the JVM exposed, while still being performant, stand alone in this field. I was wondering if any of you had similar thoughts, contradictions, or anything like that.
I want to agree with what you said in that, of course, Java has been around for a while, and possibly as a result of that, the ecosystem around Java is quite mature. So it means that there are good toolings. We had a talk about package managers, for example, at the Foojay dinner at FOSDEM last week, where we were comparing package managers for different languages. And actually, Java is not so bad, as much as we like to complain about YAML and XML and other stuff. We have it pretty good, I think, in the Java ecosystem, in that there's lots of tooling that we can use for everything from writing tests to debugging to observability, like you're saying.
I find it quite interesting when I hear people talking about Java with profiling and also with observability, with debugging, and often, if I may say, it feels like that they want to be Java to be this exceptional great language. But when I look, for example, regarding debugging into what I can do with PyCharm, it's not that far away from what I can do with Java, and it covers like 90% of my use cases, and all the other use cases can be mostly covered by just writing a few lines of code, which is easier in Python, for example, because you don't have to rebuild the whole project. And also, for example, in JavaScript, it's the same. They're really great debuggers when you look at the debuggers that you can use on the front end. I like they aren't that great as the Java IDEas because they aren't that long around yet, but they're still really great. And I feel that this exceptionalism that Java is like the best and everything Will doesn't cut it, because Java is there for a long time and has a great ecosystem, but I think every ecosystem has enough tools to debug in it, else people won't use it for production. So I think Java has good parts in its ecosystem, but it also has parts where it's missing. For example, C# is also with the .NET runtime doing a really great job in all of this. With Microsoft bringing in their own debugging protocol and their language server protocol, many languages probably gain in the future similar debugging and observability features as Java does.
Also, a lot of these features are basically language independent. A lot of observability features these days, metrics and such are all going over REST. These days, with the sidecar, you can have things like ESTO, where basically a lot of these observability things become language independent. So in that sense, Java has its agent, which may set it apart, but a lot of these things from observability can be outsourced to basically other applications, so that every language has those features.
That is partially true. If you look at agents for things like OpenTelemetry and performance agents, similarly in APMs and similar tools, and measure the scale of impact that they have on the production environment that they're running in, the JVM has better tooling in that regard, more seamless, more APIs related to that. And that's because Java's deep history in the enterprise that other tools like Python just don't have to the same degree. If you look at just management beans and the capabilities available there, and compare them to something in almost any platform. .NET has management capabilities because Microsoft does have some enterprise bona fides there, but it's not uniform around all the platforms supported by CLR. And there's lots of complexities between the versions and compatibilities there that aren't necessarily as compatible across the range of their offerings. So Java and to a lesser degree .NET stand relatively separate from the simpler solutions that are available, like Node and Python. I'm not saying that that's necessarily a huge advantage for all cases, because as you said, observability with tools like Prometheus is mostly the same for any environment that you'll use. But if you're using an APM, telemetry, or JFR, ideally, then you're getting a lot more from Java and the JVM, or any language that runs on the JVM, than you would by looking at similar offerings from other platforms at this point in time. And there's a lot to catch up there, especially when we're talking about doing that and performance, because the impact of these tools on the JIT and the runtime environment is severe. especially in Python. I've worked there on some tooling, and even the most basic hello world where you do nothing, the CPU drops like a stone in terms of performance. It's a very interesting exercise to try and alleviate that. And I know that people in the node space are working on improving that, but it has been my experience that it's a far more Spartan environment when you try to deal with those environments. And .NET a bit excluded there because it's more mature in that sense.
Just from my side, because you talked about APMs and OpenTelemetry, one of the major problems that APMs in the Java world have is that Java doesn't have a really good API where you can just, as an application or as an APM developer, can just say, "Hey, get me your stack trace." You cannot really, you have to use JFR, and that's because one thing
so you're working on that.
I'm working on that because many of the APMs, for example, taking the APM from Elasticsearch, which is quite widely used, and from other people, and also the APM from Grafana, they're using AsyncGetStackTrace, and that's an API developed in the beginning of the 2000s. It's not well supported, and as you will probably read also in a blog post after this podcast came out, it has some severe problems. For example, it doesn't have enough testing, and it can appear and can disappear all the time, essentially, when Oracle says, "Oh, we don't want to maintain it anymore." So I think Java has good parts. It has not that great parts. And I think it's still a way to go till we are in our wonderland that many of us envision that we currently have.
Yeah, it does require a lot of tuning and familiarity. The nice thing is that it's very flexible. You can write an agent in native code in Java, and it sort of works seamlessly. There are challenges, and lots of things behave one way in one version of the JDK and differently in a newer version. But in terms of performance, in terms of compatibility, it's relatively consistent for a very long time. I can tell you that we worked with JDK 7 compatibility, and things still work in JDK 17. And that's fantastic. We're able to get really good performance and still be very backwards compatible on some of these rather complex things. And as you mentioned, by the way, you didn't mention the JEP version number 435, which you've submitted for asynchronous stack trace VM API. I'd recommend people who are interested in implementing these low-level calls to check this out and see how it can impact them.
One question I do have for you all: what bits of information are you typically looking for when debugging? Because in practice, what I'm mostly looking at is things I need to reproduce my problem on my own computer. Because no matter how great tooling we have to do debugging in the cloud, debugging on my local machine will always be slightly easier. Furthermore, if possible, I can turn it into a unit test or integration test, so I can just keep running over the scenario, running the scenario over and over again. So that helps me a lot in figuring things out. So I'm mostly looking at, I need stack traces, or I need what request came in, like the request body and such, so I can reproduce things on my local machine. Is there any specific information that you are all looking for when debugging?
I use debugging also to sometimes check my understanding of the code. So just to run through it or step through it and make sure that it is working the way that I think it does. Because sometimes you read code and make assumptions and it does something else, or to check the value of a variable as it's running through the logic, or to make sure that it hits a certain branch that you think it should hit. So I use debugging for that as well. I use evaluate expression quite a lot to maybe change some things and see what happens. And the example that you're giving is you're running a unit test. You need to have a reproducible example first. So yes, if I'm bug fixing, I will, if at all possible, write a test that reproduces the problem to make sure that I understand the bug correctly, that I get the same error message that I'm trying to fix or whatever else is going wrong. And I also do definitely prefer doing that on my local computer. But sometimes you don't know what causes the bug. So for that, you can attach a debugger to a running application, which we've also done in the past, and then wait for the problem to appear.
That's a thing where some observability tools could really come in handy, which can help you with not having to actually run a debugger with what we talked about, all the security issues and everything. And that's usually what I'm looking for in my observability tooling. And of course, a nice thing about running it locally and writing a test for it, after that, you also have a test for it. So you make sure that it can't happen again in the future.
Exactly. Not only kill the bug, but make sure it stays dead.
Yeah, exactly. Johannes, do you have anything that specifically that you're looking for that tooling may help?
What I'm looking for is whether I know the bug already. So it's usually for me, what I'm currently doing is it's in the C++ world, but you can also do this in Java world, is that I have a small catalog of bugs that you already seen, and I started to record these bugs in like a text file to say, okay, here I had this bug or like this issue in this field, and now when someone comes to me and says, oh, I have this problem with another API, I can just say, oh, I know this bug already, and here's a solution that I did when I solved it in another part of the code. Or I can say, oh, let me look into this. And also what Marit said, I want to understand the code. So it's quite common for me to debug the code just to understand it, because when I'm like dropped in the new code base, for example, the OpenJDK, or I don't know, working on IntelliJ, understanding how IntelliJ does debugging by debugging the IntelliJ debugger, which is open source, it's quite cool. Do it, but your mind will be blown up and being in pieces. It's quite interesting to just drop in, set a breakpoint at the point C when it runs on it, and then use the evaluate feature. And thereby I was able to understand how the debugger uses the whole protocol stuff directly without having to comb through all the code, because this is quite impossible for a large code base.
I specifically wrote the second chapter about it within my book is about the theory of debugging, and pretty much it echoes a lot of what you said, where the process needs to go through a set of assumptions and isolations and through the issue tracker. This is actually, when you're talking about academic theory of debugging, they specifically mention issue tracker, which is weird for me, and usually when I'm reading academic things. One of the things that we talk a lot there is about the dailies and having an actual daily standard meeting with the team when you're working and communicating about the bug, because that sort of, and this is kind of contrast to the rubber ducking portion, actually talking to living people and listening to them, because that really helps in some of those tight spots when you're trying to find the right way to isolate something. Also, there's defensive coding, which I know isn't about tracking or reproducing the bug, but there are coding techniques that we can use as part of our daily programming, and the specific logs that we choose to log, and how we build our tests, and what we test, and what sort of coverage, not 100%, what sort of correct coverage we do. That really helps. And one of the tricks that I do, that I love in order to reproduce something locally, is not to try and reproduce it locally, but try to reproduce the bug. So if I see something that fails in IntelliJ, I can go to a specific method and try to reproduce the situation by modifying the state of the JVM. So one of the things I can do is IntelliJ has a plugin called Jump to Line, which you can use to sort of drag the execution pointer to an arbitrary location. And you can move back in the execution and just change the state of the VM with by setting the values of variables to match what you think the bug would be, and then just step over and try to reproduce it locally, just within the VM, without changing the entire environment, without adding all the data. And then you can go over and over again, sort of test live without recompiling, without rebuilding, and just redo everything over and over again right in the debugger. And that's a fantastic tool to retry some things that are harder, some states that are harder to reproduce because of data in the servers. But sometimes for production, because of the scale of it, you can't possibly reproduce it locally. And there we need some observability tools, and I also go into that quite a bit. Sorry, a deep plug on the book there, about the observability capabilities that you can inject there, and developer observability, which is very close to the way you debug locally, but designed for the scale of production.
Yeah, that's actually quite a cool tool. I didn't hear about that. It's very good for exploratory debugging. That's something I should look into. There's one more subject I do want to talk about, because I noticed that no matter the tools, all the tools you have available, the biggest mistake I usually see people make is, I once helped someone in the morning because he was, hey, I'm having a bug, can you help me? So I helped him a bit. And in the end of the day, asking, did you manage to solve it? And so, no, I'm still busy. I'm just trying to set this cookie, and because that's what's restricting me from solving this bug. And then I just asked him, are you sure that setting that cookie will actually solve it? And then he had to confess he didn't actually know. So, okay, let's just do a small hack, just set a cookie in a hacky way and just see what happens now. Oh, it still goes wrong. Okay, let's have another look. And oh yeah, it turned out to be something completely different. And that's the thing I mostly see people doing wrong during debugging. Go in, they already have an assumption, a hypothesis in their head to what might be the problem. And basically everything they see, they get tunnel vision towards it, and everything they see goes toward that hypothesis they had in the beginning. And this is usually what causes the most time in debugging, having a wrong hypothesis. So if you have an hypothesis, use all your tooling you have, no matter how hacky it is, to just make sure that your hypothesis is correct. And then you can start with doing a proper solution and doing proper debugging. But at least make sure that your problem area is correct.
Yes, you need a sort of tongue motion where both sides of the equation, you sort of slowly move the tongues through. And usually when you start running into a problem that becomes a deep problem, it's a process that you can stop by double verifying every assumption. And there are tools that you can use that sort of help you verify that assumption. So for instance, I can check in the ID and see that the application behaves one way, but I can also check it using an external tool like JStack and things like that to verify various behaviors. And once you have that sort of double verification, you can slowly move the tongues between the tiers until you reach the area of the code that's responsible and sort of corner the bug in. It's sort of like a hunt in a way.
Yeah, indeed.
And this is part of the theory that I talked about.
And a small trick I also learned that's very helpful is by saying out loud what your assumptions are. Like, I'm going to call this with
rubber ducking.
with this, and well, indeed, it's in that way form of rubber ducking. But saying your assumptions out loud, that I'm going to call this method with these arguments and assume it's going to fail, it makes it more true. Especially because we are, as human beings, we like to be right. So if we make a certain, if we call something and we only have in our heads what we expect it to be, then if the result is different, we just adjust whatever was in our head, which is not very efficient to do debugging. By saying it out loud, I'm calling this and I expect it to fail. If it suddenly succeeds, you can't turn back anymore. Hey, this is weird. I should figure out, was my assumption wrong? Or is the code basically actually doing something that I didn't expect? So that's one of the biggest tricks I learned, and it's really helpful.
I'm also curious what kind of information you'd look for if you don't know where the bug is. And Ties, your example was I would try to reproduce it in a unit test or check it locally. Of course, that works if it's functionality inside your application. Sometimes you have bugs that are caused by specific data on the production environment, but you don't know what it is. I'm going to go with control characters are fun in XML, for example.
Right.
A friend of mine told me where they switched OS that the JVM was running on, and the new OS didn't have a certain default that they needed in their application. So these are things that sometimes you can't reproduce locally. So if you have, like Johannes, a Heisen bug where you study it and it goes away, what are some of your techniques for tackling those?
So one of my pet favorite bugs here is the data corruption bug, where you suddenly start finding in the database bad data that came from someplace and that you don't know who inserted that data. And it's some part of your app that did that insert, but you don't know who's responsible for that, what part of the code is responsible for that, because lots of code invokes that. The problem is you don't have a stack by this point because someone received the call to make that, and the symptom is very problematic. And there's lots of those things where the symptom is so far away from the actual bug that there's no stack trace, there's no trail by then, it's run dry, and you sort of need to set a trap to find the bug. But this is a problem because you need to leave the bug running in order to sort of chase it back through that trap and find all the paths to it. Sometimes it's unfortunate, and this is the only way where we need to set a trap and just add verification to sort of find it and hope to reach that place correctly, or set a constraint in the database and hope for the best. Another approach that we try to do to solve that before we reach that worst case scenario is to understand that separation between the root cause and the symptom itself, because there's still a limited amount of things that would, for instance, in the case of a bug that writes bad data to the database, is still a limited amount of code that can invoke something that would write bad data to the database. And in those situations, you start verifying, trying yourself to cause that bug in an integration test. And in every such integration test where you're capable of doing that, just plugging that hole and preventing that sort of data. And essentially, I look at it as sort of hacking debugging, where you try to sort of hack your system blindly in all possible attack vectors. It's obviously a challenging approach, but that's the only way other than trapping, which it isn't a fun process to trap. Ideally, if you have observability, then you can sometimes track something back, but that's difficult, and you need a lot of logs to comb through, and it's not a trivial thing.
The things you're saying about is going back to what you started with. It's by reducing the problem space. Those are all the things you described, but just techniques to reduce the problem space. And the question, Marit, is very difficult to answer, since it really specifically depends on what's going wrong. But the only generic answer for that is reduce the problem space with whatever means possible. If that means indeed just setting traps, doing log statements, that's a way of reducing problem space. Doing all the hacking is just a way of reducing problem space. Running it on a previous older JVM, just because you did an upgrade, just see, does it still happen on the old JVM? That's reducing the problem space. The context it's impossible to answer that. But one step back, the abstract way of looking at it is asking yourself the question continuously, how can I reduce the problem space? And whatever means possible. That's basically the only concrete answer I can give to that, even though it's not very concrete.
But I love that you said context, because that is everything. It really depends on the type of bug, the type of application, what type of information you need or what you need to look into.
Yeah.
I think that, with experience, I really, really love what Johannes said about keeping basically a bug collection of, these are the bugs I've encountered and this is what was wrong. I really love that, because with experience, you're going to be like, I've seen this before and it was, this, that, or the other. So that's really cool. And also what Shai said about your dailies. And if you have a bug, if you tell your team, I have this bug, someone might remember, I've seen something similar. I've also had debugging sessions where I was like, okay, something is going wrong. Let me check, 1, 2, 3, 4, 5 things. I can't find it. Go to the next developer. Can you help me fix this? They check the same 5 things. Okay, that's not it. We go to the next developer. He checks the same 5 things and then checks number 6 and 7 and finds what was wrong. So yeah, I'm a firm believer in also just helping each other out, basically.
Yeah, pairing can help a lot. And also be conscious about these problem-solving techniques, as in do not make assumptions, producing problem space. Like these are things that if you get experience, you automatically start doing. And that's what I noticed, that it really helps to take a step back and consciously try to think in those terms. That I should be doing this, how can I do that? Instead of basically go with the flow and rely on experience.
And to get back to what we said earlier about technical tools that you like for debugging, Git bisect is great if you have a test that fails, but you don't remember when it started failing. And speaking of discoverability, I don't think that's really great on Git either, because if you've never heard of Git bisect, how are you going to know that that even exists? But yes, it is a tool that I have used to locate when a bug started and in order to fix it. So
yeah, I have a blog post on Foojay where I have a meme called that says our Lord and Savior Git bisect. Very much with that specific tool. And those who might be listening and don't know about it, Git bisect essentially discovers a regression for you automatically. So if you have a regression in the code, just tries all the permutations and finds the specific revision in which the problem started. I'd like to thank you very much. First of all the guests this episode, and thank you for listening. Keep an eye on Foojay for future articles about development and everything related to the Java world. Thank you.
Give me a Foo, give me a J, give me the friends of OpenJDK.